Most modern buildings are engineered to last around 50 years, maybe 100 if we're lucky. Reinforced concrete and steel dominate skylines, flaunting strength and efficiency. But beneath the shimmering facades of contemporary cities lies an uncomfortable truth. Modern materials may not be as timeless as we think. Meanwhile, a city floats on water, literally. Venice, the historic marvel of northern Italy, is still standing 1,600 years after its founding, built not on steel or concrete, but on wood. Yes, wood. Not only does it still stand, it thrives. Its ancient structure is held aloft by millions of submerged timber piles. This isn't just a curiosity. It's a case study in how modern engineering, for all its advances, might have missed something profound. So let's dig into how Venice defied the laws of decay and why we might have taken a 1,600-year engineering detour. Venice, born on March 25th in the year 421, is often described by locals as an upside-down forest. That's no metaphor. Beneath the canals and the iconic stone palazzos lie millions of wooden piles, short timber trunks from trees like oak, larch, alder, and pine, driven deep into the soft sediment of the Venetian lagoon. These piles range in length from less than a meter to around 3.5 meters and are pounded with their pointed tips downward. Their purpose? To provide stable foundations in waterlogged, unstable terrain. Beneath the iconic Rialto Bridge alone lie 14,000 wooden poles. The Basilica of San Marco, supported by 10,000 oak trees. This massive operation wasn't a one-time job. It was a culture, a craft. The battipali or pile drivers hammered each pole into the silt by hand, guided by experience, rhythm, and even song. They sang haunting melodies to maintain their timing, praising Venice and invoking strength and resilience. Engineering was ritual, not just calculation. Reinforced concrete and steel, mainstays of modern engineering, aren't inherently weak, but they're engineered with a different philosophy: efficiency, speed, cost. According to Alexander Puzrin, professor of geomechanics at ETH Zurich, modern structural standards guarantee 50 years of lifespan. They may last longer, but the minimum acceptable benchmark is sobering. By contrast, Venice wasn't built for short-term gains. Its design embraced the natural forces it rested on: soil, water, and wood. That synergy created something more durable than most of the day's reinforced foundations. Puzrin recalls being asked once to guarantee a building for 500 years. It was so unusual, he had to call his boss. The response? Sign it. None of us will be around anyway. And yet, Venice is still around, still standing on those same wooden feet. What made Venice's wooden system so robust? Part of the answer lies in the way the piles were placed. Each pile was driven in a spiral pattern, 9 per square meter, starting from the outside and moving inward, once hammered to refusal, meaning they couldn't be driven further. They were sawn flat to form a uniform surface just below sea level. Then came the transverse wooden beams, Zatteroni or Maggieri, laid on top, sometimes up to 50 centimeters thick, depending on the weight of the structure above. Finally, the stonework began. It's an elegant layered approach: mud, timber, water, and stone. And all without engines, cranes, or CAD software. Just knowledge passed through generations. To feed the endless need for timber, Venice became a pioneer in sustainable forestry. As early as the 12th century, the Republic of Venice began protecting its mountainous forests, not out of modern environmentalism, but necessity. Nicola Macchioni, research director at Italy's National Council for Research, says Venice essentially invented silviculture, the practice of cultivating forests for wood. The Fiemme Valley's Forest Management Code of 1111 AD is Italy's oldest known forestry document. While England faced deforestation by the 1500s, Venice's careful planning kept its timber supply intact for centuries. The city wasn't just preserving wood, it was preserving its survival. A common belief is that Venice's wooden piles haven't rotted because they're submerged in an oxygen-free environment. While partially true, the real secret is more complex and more fascinating. These piles don't rest on bedrock like modern foundations in Chicago or Amsterdam. Instead, they rely on friction, specifically skin friction between the wood and the surrounding saturated soil. The more piles packed in a given area, the greater the grip. This technique is ancient. Roman engineer Vitruvius mentioned submerged piles for bridges. The Aztecs used them beneath their temples in Mexico City. In China, water gates were stabilized with similar methods. It's not about brute strength. It's about working with natural forces. The dense placement of wood, combined with hydrostatic pressure, creates a frictional bond that distributes weight evenly, even in soft soil. Still, Venice isn't immune to change. Over time, anaerobic bacteria do attack the wooden piles, but their progress is slow, much slower than fungi or insects that need oxygen. A decade ago, researchers from the universities of Padova and Venice examined Venice's foundations, including the Frari Church's bell tower, which had been slowly sinking, just 1 millimeter per year since the 1400s. Their findings were a mix of concern and wonder. Yes, the wood showed signs of bacterial degradation, but the combination of waterlogged soil, mud, and hydrostatic pressure was maintaining the pile's shape and strength. Even damage retained its structural form, soaked and compressed into long-term resilience. The key takeaway? It's not just the wood. It's the entire ecosystem beneath Venice. The synergy of soil, water, and timber that creates the strength. Remove one element, and the whole system collapses. In the 19th and 20th centuries, cement replaced wood in foundation design almost entirely. The perception was clear. Wood was old-fashioned, perishable, weak. But now that narrative is shifting. Wooden architecture is experiencing a renaissance, from mid-rise apartments to towering wooden skyscrapers. Engineered wood products like cross-laminated timber are now praised for their environmental benefits and earthquake resistance. Wood is kind of the cool material again, says Thomas Leslie, architecture professor at the University of Illinois. It's a carbon sink biodegradable and, if used wisely, astonishingly durable. Still, scaling Venice's method today is nearly impossible. Our cities are too big, our population's too dense. But the lesson remains. Ancient builders, with no formal education in soil mechanics, harness physics, intuition, and nature's gifts to build something we still marvel at. So, was switching to steel and concrete a mistake? Not entirely. These materials gave us the industrial boom, the skyscraper era, the rapid urban sprawl. But perhaps we focused too much on speed and not enough on time. We built for now, not forever. Venice, by contrast, was a long game. Its builders didn't just construct a city. They cultivated a foundation system that worked with the environment rather than against it. The real mistake isn't choosing steel over wood. It's forgetting that building isn't just about what goes up, but what holds it up. Venice stands today not because of magic or miracle, but because of mastery, of material, of nature, and of time. It's a testament to what's possible when engineering embraces patience and harmony with the earth. Perhaps the next revolution in construction won't come from futuristic materials, but from rediscovering the wisdom buried beneath 1,600 years of watery silence. When wood beats steel, it's not a victory of nostalgia. It's a reminder, a lesson, and perhaps the blueprint